Meter configuration involves hitting the two outer buttons. We're going to put password 4000. Third button to the right, 1, 2, 3, 4. When they're there, hit the two outer buttons. Now we have either parameter, calibration system, record view, diagnostic, output, communication, function, parameter. Parameter is where you're going to adjust the full scale and the units. Double click parameter. We can look at the diameter. We won't be able to change the diameter because menu 4000 doesn't allow that. And we can check the liquid density and change it if we want. You do that with the button. So I can move this button around, 1000.1 or 9, whatever it is. Double the out buttons to save. Excitation current, excitation measuring range. This is for full scale. So notice on the right, as I'm clicking over, when the cursor becomes large, we can look at the units. The units can be changed elsewhere. This one is cubic feet per minute. Mostly folks are using things like gallons, but I'm showing cubic feet because it's a new unit we've added for some of the cement industry. And then the volume unit, two outer buttons, and actual foot, cubic foot, barrel. What most people use is gallons. We're going to be adding 10 gallons. So this is an improvement over our original unit. And flow unit, here's where we could change the units. So change them there. So we're going to do cubic feet per minute on this particular meter. And damping time, 8 seconds is a good one. You could change it 98 or 0. Two outer buttons saves. On this, now I'm going to hit the enter button, parameter. I'm going to go to calibration system, diagnostic. I'll show that in another video. The purpose of the diagnostic is to drive the 4 to 20 milliamps. This 4 to 20 milliamps is self-powered. It means that you do not, the 4 to 20 milliamps is self-powered, which means you do not put 24 volts into it. Right now, the 4 to 20 milliamps is saying 4 milliamps. So when I click the outer two buttons, this thing will flash, meaning that it's creating the condition of 10 milliamps there. And if I click it again and select 20 milliamps, hold the 2, notice the flashing, it'll drive 20 milliamps for you to check your PLC. It's critical that you do not inject 24 volts DC into this machine. When we're out of the test, it goes back to 4 milliamps. So the output communication, this is important for setting up Modbus. So we have Modbus address, two outer buttons, address 1, the check bit, none even, so no check. Baud rate, 9600. There aren't many choices here. We go to 19.2, 38.4. So 9600 is kind of like the go-to for most PLCs. Save. After that, we have Modbus diagnostics, two outer buttons. This will be the strings that are being sent to the device. I will cause, I'm going to read register 55 4 bytes. And we can see, with enough study, you can see what's going on. Read those things, there's CRC and all that in there. Function, and that's it. And to go back to where we are, long hold the right button, and we're back. And we could cycle through the percentage of flow, what the velocity is in meters per second, what the difference between the plus and the minus is 22. So we have minus 56 and plus 79, the difference is 22. That's what that's for. And empty pipe display alarm. So it has, there's no fluid in this one, and that's it. We show the inside of the enclosure with the power, 24 volts DC, 0.5 amp max, plus on the right, next to the plus, minus on the left. Here's a place to put ground. These terminals are for the sensor and coils on the mag meter that make it a mag meter. This is the RS45 plus and minus. This is the 4 to 20 plus minus. And the plus, this 4 to 20 is self-powered, meaning do not put 24 volts into this device. This device takes more than 4 milliamps to run, therefore it's not a loop-powered device. So the 4 to 20 is you configure your PLC as though it were a fluke meter. So that's a self-powered device, and that's it.